Hi everyone, thank you very much for joining me again. Today we continue our discussion with cross-site request forgery protection or CSRF, and we'll discuss about what CSRF is and how Spring Security helps you avoid CSRF attacks through its mechanism that protects you against this kind of attacks. So we will start by discussing what CSRF is, and then we will work a bit on code, and I will show you how CSRF protection is implemented behind the scenes. And hopefully with everything that we'll discuss today, you will be aware enough of how this is implemented in Spring Security, and I think most importantly the fact that you can't simply deactivate it, because I think this is one of the most encountered mistakes I found out there throughout the past few years with Spring Security. Hey, this endpoint doesn't work, just disable CSRF, it will work. No, it's not always. I mean, in some cases you don't need CSRF, but if you need it and you disable it, then it's a problem. So if you're watching the event live, of course, I say hi as well, and you can ask me the questions in the live chat, and you can also start whatever discussions you want in the live chat. I always have an eye on the live chat as well. If you're watching the event recorded, ask the questions in the comment section or find me on Twitter and LinkedIn. Let me share you my screen and start with a discussion on what the cross-site request forgery attack is, and then what is the way in which Spring Security tries to mitigate this attack. So I just prepared two icons in advance for that, and it's a simple guide that is accessing a website. So the website can be any kind of website or simple application that they use for work. Let's just assume for fun that this is actually an application they use for work. So they have, of course, logged in the application. CSRF, in CSRF we discuss about what happens after someone logs in, so they are already authenticated. And then they try to do any kind of mutating action. So a mutating action is when you change data. CSRF is an attack that is only applicable for actions where change data is implied. So it doesn't work on any kind of action that doesn't change data. It's not about stealing information. It's about changing or executing an action or on someone's behalf. So after they have logged in, so the first arrow, if you want, we can put it a little bit upper. We can say login, so we know for sure that the user has already authenticated, and the question is, can someone execute something on their behalf after they log in? And depending on how the app's made and if it's protected or not, the answer is yes, it might be possible someone executes something on their behalf. So imagine this, they have logged in, and this is a very simple application that uses a server session-based authentication. So we have a server session here that takes care of the keeping in memory the fact that the user has logged in. This is something that was very common, like it still is common, just that now we use that only for very small applications. So you already know that something like this doesn't work for large applications with a lot of requests, because you can't really scale it easily on horizontally. But for small applications and for everything that was a website, like in the first years of web apps, and that was, I wouldn't say that's something that was far away in the past. I think it's quite recently. Again, we still find this situation nowadays. It's not like it's never there. We are just more used now with client-side authentication for at least big apps. But what happens is that now the application considers them logged in. So imagine the following scenario. Someone sends them, so this is my user, and someone sends them an email. And in the email, they have a link, a malicious link, which redirects the user to a website that might contain a script, like a JavaScript, or simply somehow tricks the user into sending a request to an action that already exists here. So say this is the action, I don't know, delete something. I know usually don't put verbs in the path. Maybe it's even better to make it RESTful. Say delete invoices, and then you can understand delete is in this case the HTTP method. And what the email here sent does is somehow trick the user into executing the delete invoices method. How can that be possible? Well, it's very easy. You can have in the email something that tricks the user to click on and then sends the delete request to the server. Because the user has already authenticated, the application will not make a difference between if they actually click the button in the website, on the client side, in their browser, or they clicked something, a button on something else, or somehow else they got into sending the request. And then the server in that case will execute the delete invoices request. And that's bad, isn't it? Because in that way, you can trick someone executing actions that they don't want to execute. Of course, to go back a little bit, I said that this is possible only for mutating, like delete something, create something, change something. For get, it's not the case, because, well, you can trick someone into clicking a get request, and they will be replied with some information, but then the information cannot go back to those who had sent the email or the SMS message or the push notification or whatever means we have nowadays to send this kind of trick attacks. So the get and anything related to getting information is not affected by cross-site request forgery attacks. It should be something that leaves traces, changes something, deletes something. Okay, so that's how it works. So it's about tricking the user into executing an action, and because they are already logged in, and because this is a server session, the server doesn't know that the request is somehow just a trick request. The user had been tricked. Someone was this way able to execute something on their behalf. The user doesn't want that action to happen. They simply don't know that it happens. They simply opened an email, clicked on a link, and a request have been sent. They might even find out later that this happened, because they might not be even in that part of the application from where delete invoices happen. So you see, this is pretty tricky. If you have this situation like this, and you have a server that manages the session on the server side and serves the front end, and then takes any kind of requests from that front end, it can be in danger for cross-site request forgery attacks. So you need to have a way in which you make sure the user can't be tricked into clicking on something and someone else fakes a request on their behalf. Let me see if I can answer the questions that you have. I guess CSRF and Course are related. Yes, they are, and at the same time they aren't. I mean, they are different things, but they might come together in some situations. In some cases, Course might be helpful in avoiding also CSRF attacks. I will explain immediately, but you can't rely on the fact that you have Course enabled and assume that CSRF will not happen either. So course on which we will discuss maybe in a different lessons, maybe even next time, which is crossover resource sharing, is a restriction that doesn't allow a browser to call a different domain than the one where than the one from where the site has been taken. So if you have, let's say, you are on example.com, and example.com, the browser tries to call, let's say, api.example.com, that won't work by default. But and in that case, you can say that CSRF is not possible either, because you just blocked it through course. But it's not necessarily the case that anytime it will be from the browser itself. It can, there are several ways in which the request can be faked, and in some of them it's simply just they can trick, I know, the browser, send the request through a plugin or something like that, and in that case course doesn't help you anymore, you know. So CSRF and course, they should be treated differently anyway, even if in some situations maybe CSRF would not be possible, for example, because you have course. Like we get error and enable course, then endpoint is available for new front-end app. Okay, yes, I think that's what we both of us had in mind, and that's also, I think, what I have explained. If we are completely relying on our security on JSON token and we are stateless, we are out of the box safe of CSRF attacks, because the JSON web tokens and tokens, OAuth, OpenID Connect in general, it's a different mechanism. Then CSRF doesn't apply here. It might only be applied if you have an authorization server that is session based, where that app itself would be then susceptible for CSRF. But your resource server, if it's already based on tokens, then it's already something else. It's a different mechanism, and we don't discuss about CSRF there. You will see that Spring Security actually even disables CSRF by default in that case, which is something that you don't even care and you don't have to take yourself care of. Let's say we should not use get method to change something. Should appropriate method post put? Of course, that is one of the most important things that a developer should know, and that comment of yours, LTS, is very, very true. You should never use get or options or any other method that is not related to changing things to change things. Technically you can, yes, you can create a get method that adds something in the database, or creates a file somewhere, or sends a file, or sends a message, or whatever you want, because like get, post, put, delete, these verbs, they are only a standard in the end. You can misuse them, unfortunately. No one can force you do something like do always a read on get, but yes, that's what you should do. You should never use get for mutating operations behind the scenes. If you have a get endpoint and it mutates things, then it doesn't even matter you have CSRF enabled on your application. Someone will be able to CSRF you even if you have the protection enabled. So that's a very, very true thing. Okay, new authentication server and open, it was fun. Okay, glad to hear that. It's mandatory to enable CSRF always, not always, again, so it's only when it's applicable. And I was discussing this right now. It's when you have a server session and someone can trick the user to click on something and then call an endpoint while they can be considered being logged in. If you have an authentication based on, say, JWT tokens, then that can't happen anymore, because someone sending an email doesn't have a token unless they somehow made it throughout the authorization server, which is of course something else, not CSRF anymore. Okay, so CSRF is an attack possible when you can trick the server into thinking that the guy really wanted to execute a mutating operation. And of course, is usually applicable when you have a server session. They have logged in, so they are authenticated. So anything that they send will be taken by the server as being something they've sent, and the server believes them as being authenticated, but they didn't actually wanted to send that because they were actually tricked on sending that request from, I know, an email, for example, message or anything else. Okay, I think if you set an HTTP only cookie and you're still vulnerable, I'm not sure. We have to discuss that. I don't see any relevant link between the HTTP only cookie and being vulnerable to CSRF when you have JVT, but I might be wrong. I don't say you are wrong and I'm right, so I don't know everything either. And no spin security book for a voucher today. No, sorry, so today no spin security voucher. Okay, with that being said, let me continue because I want to finish my discussion today. I will take the rest later. So I hope that this is you understood what CSRF attack is. Now, how do we protect the user against this attack? Well, whenever they load the website, even after they've logged in, okay, anyone to get the website on their browser, they have a GET request. So even before they log in, you have to agree with me that someone sends a GET request, say get example.com, and then in response, I put an arrow in both directions. In response, they get the content of the client: HTML, CSS, JavaScript, images, whatever composes that web application. So we know for sure that there will be GET actions before anything that can be sent to the server. And what can we do is that in the response, in this case, we send back, maybe it's better if I actually really draw a couple of arrows. So let me do like this. In response to this GET, the application sends a token. To avoid confusion with what we discussed earlier, the access token and stuff like that related to OAuth, this is called the CSRF token. So it's a token, but it has a different purpose. The CSRF token is of course random, it's known by the server side, it's associated with the session somehow by default. The CSRF token is also session based, and it kind of makes sense in 99.99% of the cases to be linked to the session and be kept on the session. That's why that's the way we'll also have it in most cases. And then the idea is whenever anything that is based on a non-get method, like post, put, delete, any operation that represents mutations, they have to contain the CSRF token on the request. And this way someone cannot trick you anymore, because that would imply that they somehow found out what the CSRF token is. And well, I'm not sure if that's possible or not. Maybe it is, but you have to admit that it sounds really difficult. Okay, so that's basically it. So it's just a way in which the server, because it has a session, it wants to make sure only that session, only what comes through the web page is accepted here. The web page knows the CSRF token. Now, only requests containing the CSRF token will be accepted. Someone sending from outside, they don't have the token. So even if the guy would click the link in the email, that would initially cause the request and get them into a CSRF attack. Now it won't, because it doesn't contain the token. So if this is the one, then it doesn't contain the token, then the CSRF mechanism will protect them, will reject the request. So this is how it works. I will take again, because I see there are a lot of questions today. Thank you for that. And then I will get into some code. If you store the token in web storage, then you would be safe against the CSRF. I think what you say is just a matter on the client side on how the token is used. So it might be, yes, in that case, if you put a problem like this, I can understand your point. But I was most focused now to explain you the idea of what's on the server side. Because guys, I told you from the beginning, I'm a backend developer, not a front-end one. So yes. Indeed, if you don't correctly manage the token and it gets somehow stolen or misused, then yes, of course, it will be a problem as well. So I'm not going into what happens if the front-end app is not implemented correctly by any means. We build an authentication based on the session, but we expose the REST API consuming. Not really. I mean, that's the point. If you are based on server session, you expose REST API, then you are susceptible for CSRF, unless you use access tokens and something else. You are exposed for CSRF. So no, if you disable in that case your CSRF protection, then someone would be able to CSRF you. So no, in that case, if you have a server session login, please do use and do keep enabled your CSRF protection. How does an attacker know that the applications I use in my network, if they get a token? I'm not sure if I understand the question. Actually, what means if they get a token? No, I'm not sure if I understand the question. So if you can rephrase it, I could try to answer it. Course can prevent AJAX requests originating from another origin, but they won't be able to prevent from requests. Correct. That's something I've said a little bit earlier. Good. No. Okay. Can you get Spring Security book? No, I said I don't have a voucher today. Sorry. A sessionless method for CSRF exists, which can make your server stateless and don't hurt scalability of your server. The physical double. Okay, I think we get into something totally different. So let me continue with what I wanted to tell you today. So let me create actually a project and discuss some Spring Security, because it's already 20 minutes and we didn't see any Spring Security yet. So I say SS 2022 C18, I guess is today, and what do I want to add as dependencies? I'm building a web application. I use security, of course, and because I want to show you something in regards to the client side as well. I'm not a front-end developer, but I should be able to use TimeLeaf to create a simple form. And that should be helpful enough for our demonstration. So let me create this the way it is. Wait a bit for everything to be indexed and start with a very simple page. So I want to just have a very simple page for the beginning and see what happens if we try a post operation. See what happens with the login, because the login is a post as well, and then understand how the CSRF works behind the scenes. Okay, this is it. So let me be very quick. I will just create a demo controller, and because it's a web page that, by the way, I would like to put it on the resources here, templates, HTML, index. That will be a simple controller, not a REST controller in this case. It would be a REST controller in case you have APIs, but in my case I won't have. And then I have public string index and the simplest of the page is mapping the root to index HTML. And if I'm starting this, should be able to use a browser. Let's make sure that starts first. A lot of time because I didn't download the dependencies in advance this time. I always forget to do that, but let's hope it's not that much in the end. In the end, it's only a couple of dependencies that I have added, so they should build fast enough. And it's starting now. Again, by default, so you see I have no configuration class, so I will rely on the default configuration since I've added Spring Security to my POM XML file. So localhost 8080 redirects me to log in because I have Spring Security as a dependency, and then I can log in here with whatever I want. So what can we check about this? If I'm going to the page source, is that somewhere in the form you have a post operation, so that is already something that it's not get. Can you see what happens here? So automatically Spring Security added this CSRF token that has been generated. So when I've requested the website content, I got also the tokens. I got all the content, including the token where I need it, meaning whenever this form will be submitted, I will get the token. So when I will post, click the submit button, the sign in button, which is the submit button, and when I will post, send the request, the token will also be sent, and then the server will recognize that the request is a valid one. So that should happen not only with the login, but with any operation that is a post, put, delete. Not forget get. If get would of course be protected in this way, then you would have no way to get the information. Okay, then I don't have a user and the password, but we don't care too much about this, because what I wanted to say, I put this here just to show you first the login screen, okay? But I don't want to discuss about login today, because I don't want you to understand that CSRF protection is necessarily based on the login screen. I see that many people at first they confuse the login with CSRF. They somehow think they are connected, but what I will prove you today next is that with or without authentication, CSRF still is in place. And then what I want you to remember is that it doesn't matter you have or not permit all on the endpoint, CSRF is still there. Because sometimes I see people, the developers say, I think even last week I had this question from one of my colleagues, why is this not working? I have a permit all on this endpoint and I have a 403. How is that possible to have a 403, meaning forbidden, meaning unauthorized, but I have a permit all on the authentication? And I took a look and I saw that the endpoint was a put endpoint. Being a put endpoint, guess what? The CSRF protection is enabled. So unless you either manage it somehow, the CSRF, or you simply disable it for that endpoint, or whatever the case is, it will not work. So that was the case, and I want to show you. So let me not a new Java class. Actually, I want the package first. Let me create a configuration file, disable the authentication, so security config, configuration, security filter chain. Okay. Nope. Build. And HTTP authorized requests, any request, permit all. So you have to agree with me now that the login page should not appear anymore, okay? No, of course, bean annotation, otherwise we don't have it in the context and nothing will work. Or at least it won't work according to what we expect it to work. And restart the application to see that. So I'm going back to my browser. What did I do? Did I close it already? This is the one. And if the restart worked already, when I access it now, I should have no login screen. It's not started probably yet. Come on. Still not started. Okay, now it did, so I'm going back. No, not this one, this one. And it drives me here to, like, probably this is the page, the default page. If you want, we can prove that's the default page. I have some Grammarly plugin, but that's not mine. But you can, like, if you really want to see this is the page, you can just put this in body here and make sure is the page. Something like this. Anyway, I don't have anymore the login. Does that mean CSRF doesn't work? No, CSRF is a totally separate mechanism from the authentication one. And it starts from a totally different filter that I will show a little bit later. So no, even if I disabled authentication, I will prove now that CSRF still is enabled. How can I prove that? Well, I can prove it by trying to add a simple form. I will try to add a simple form. Like, to prove it, only one button should be enough. To a specific action that I will define, which should be something that's not get. So public string, do something with a post mapping or a put mapping or a delete mapping, whatever you want. And to make sure that this works, let's also use a system out, because I don't want you to, I don't believe that maybe it happens because you just see the same screen. We need to make sure we prove this really doesn't work, okay? So something, and that means something on the action, and of course the method. So does this work? It shouldn't. It shouldn't, because we didn't provide the CSRF. You see the CSRF nowhere. So when I will click the boom button here, because the request doesn't contain the CSRF token, it should be rejected. And that's at least what I expect. I hope that's what will happen. I'm refreshing and I'm clicking the boom, and I get a 403 forbidden. And I'm pretty sure I know the reason for this 403 is the CSRF protection. I can check the console. I don't see any smiley face, so it means that indeed this system out here hasn't been called. And what's pretty nasty with CSRF is that if you don't enable the debug, you will not see anything in logs. So it's if you maybe don't have enough experience, it might be difficult to find out it's a CSRF in the first place. But in this case, it is a CSRF. I should be able to prove that by showing you how to disable CSRF. And whenever I tell you how to disable, I would also say, I would be tempted to say, don't do that. Don't do that. Now, I know there are cases where this might be needed. Like, for example, in some cases, I had clients that really implemented on their own OAuth 2 and or an OpenID Connect. They implementing a specific way of authenticating and authorizing based on tokens, something custom, and then indeed they were not in the situation where CSRF could be possibly happening to them, and they had to disable it. But the reality is that in most cases, when I've seen people developers disabling CSRF, was simply because they didn't understand what it is. They simply saw it's working when you disable it, and in some cases they even told me, well, I searched on Stack Overflow and I found someone telling me that if I disable this, it will work. So, and that was everything. They simply saw on Stack Overflow that you can put disable, and yeah, now it's working. I will leave it like this. Oh, damn. No, that's not. At least if you think that CSRF should be disabled, make sure this is the case for you. Make sure you understand CSRF. Make sure you understand it for your application, for your case, and disable it only if that really is the case for you. If that really should happen for you. So I'm going back here and I'm going to click the boom button. You can see here I can click it, no more 403. Why? Because I disabled the protection mechanism. So I still don't have a token. I can see that everything works now. So the smiley faces are written to the console when I click the boom button. But that doesn't happen because CSRF works, is because I actually have disabled it completely. One more trick. Now I'm going to comment this out because I don't want this to remain like it should happen. One more trick. Instead of disabling it, you can simply just, like, let's say you have an endpoint for which you want to disable it, because I've seen that as well. In a project at some point I've been told, well, we disable CSRF because we have that post endpoint that's called from a service. It actually is a post endpoint, but it doesn't change anything. But it simply didn't work because if it being a post and we have CSRF enabled by default, the server couldn't call it. And I was okay, and you disabled like the whole CSRF mechanism because you had one endpoint that didn't work, and that in that case, of course, for that endpoint it wasn't a problem. But did you think about all the 1,000 others? Okay, if you want to ignore it, to ignore the CSRF for one or for multiple endpoints, you can even use ANT expressions here, you know, you can do like this. So you can say, please ignore CSRF for these specific patterns that I enumerate as parameters of the ignore request measures. So yes, I could have simply ignored my do something, or however it's called, because I forgot. So my something, I could have simply just say ignore this path, and that's a lot better than disable. Okay, so if you have specific endpoints for which you have analyzed the case and it's not a problem and you want to disable them, then you don't use the disable method, you use the ignore request measures, and that should be it. Okay, so from here, maybe worth mentioning that there is also the somehow opposite of ignore. If you want to have specific endpoints for which you enable, then you can do that through the require CSRF protection matcher that gets as a parameter a request matcher defining which are the points for which you want to require CSRF. When would you use something like that? You are in a situation like where you don't need CSRF because say you use JBT tokens. However, you still want to enable CSRF for a specific endpoint for some reason, then you can use the required CSRF protection. So what I would recommend you is usually don't disable CSRF. Usually think about if you don't have to enable it on purpose for some cases. Okay, good. So I commented this out. Can I make my form still work even if I have CSRF enabled? And the answer is yes. In any case, you can, anyhow you'd like, just make sure you end up with the CSRF token on the request. So in my case, in this case, I can even use a hidden input, and I can use, in my case, timeleaf to say the name. I want the name of the token to be added to this. So I just want to say th name is and then I use an expression CSRF header name, which is usually CSRF, but don't necessarily rely on the header name because it can be customized. So in Spring Security, you can actually customize the way the header looks like. Is when you want to do that, you can actually customize your entire mechanism. Like for example, the CSRF token repository you have here. So that's why I wouldn't recommend you rely necessarily always on the defaults. You can do that, but you can simply just make sure that you take the header name from the request attribute. And then you have the value, which is from the CSRF request attribute, the token key. So if I'm restarting now, I will go back after restart to my browser and especially to see what happens here in the, in the elements. So going back in the form, you can see what happened. So this name X CSRF token is the default one, and then the value is whatever the Spring Security mechanism generated behind the scenes. Now this input hidden will be sent together with the form. So when I press the boom, I get the 403. I have no idea why, but it should actually work. I wanna figure out exactly why. Very interesting. Let me check again if I actually restarted. Okay, now I don't know why I have a 403. So now I have 405 actually. Oh, 405. Fantastic. So it's not a 403. Yeah, because it didn't make sense to have a 403 because the token was there. I have a 405. Why do I have a 405? Didn't I have post here? 405, from what I recall, means the method is wrong. I think it's because of this HTML here. Or it simply wants a redirect, something like this. Which should be timeleaf related, not Spring Security related, by the way. And then I can apologize because I don't, I can't say that I necessarily know very well how to use timeleaf. Now it's a 403. Okay, I don't know. I will check on this because I'm not sure exactly what happened, but I see the token is there, so I'm pretty sure I made everything right in terms of the input. So see the value here looks fine. I have the value, I have the token, fine enough. Let me see here one more, but it looks okay, so it's a bit strange, but anyway. We can actually even go, and I wanted to go there with you, say CSRF filter, and if you want to see where the filter, where is the filter where the CSRF mechanism starts with, is basically this filter that should be part of the filter chain once you have it enabled. And I can start it with a debugger actually to see that. Okay, so I can go here, say, okay, you already see that my debugger stopped. So now is the first get, is when the token is generated and it will be added. So I did add it to the request. That's what happened here. Now I think my debugger actually stopped, but it was in this if, so the request doesn't request, you see it's in the if where it says that the request doesn't require CSRF protection because it was a get request, so it simple filtered out and then it exited. But when I will click the boom button, then it will say that it should enter basically the else block. That's the expectation, because we are in the situation where it needs a token. And it says, do we have a token? Yes, this is the token, and this should have, oh look, this looks like the problem, isn't it? So it looks like it didn't get a token, so my request somehow is not correct, so that's why it's failing. So it expects a token, but it doesn't get the token for some reason. I can investigate exactly why it didn't get a token, but anyway, we know at least the reason why it's failing. This is probably now going to say missing token. No, it's not missing, but then I don't understand. It was actually, so say request. Because I was under the impression that the token is null, but maybe I was actually wrong. No, I actually have the token. Is this UUID here, but the token looks a bit different. No, it isn't looking a little bit different than what we've seen here in the browser. So this is what I expect to have been sent, this one, and I actually see that one. Okay. Sorry guys, it's my fault. So it's the I was using something else, not the parameter name. So indeed, because the name was not true, the token was not found. So that's why it happened. So let me change this and try again. So I was using the header name instead of the parameter name, the request. I think I said request attribute, but I simply used header for some reason. So let me see if that solves our problem. Ooh, it looks like it's working. And then we can see also the smiley faces inside. Cool. So yeah, the CSRF protection works well. It's just my mistake that I was using the wrong name of the input. Instead of using the request parameter name, I was using the header name, and that was the problem. So yeah, but with that occasion we also went into the internals, and you have seen, and now basically from the internals what I'm most interested in, you've seen it's a very simple if else. Does it need protection? Then it verifies the token. If it doesn't need protection, then it's simply just forwarding the request in the filter chain further. Now here it is. The token repository. So the token repository is something that you can customize. So you can just say HTTP CSRF token repository, and you can define your own token repository that simply tells Spring Security how to handle the tokens. So by default, the tokens are handled in the session, which again makes sense for most of the cases. So in 99% of the cases, probably it's more than enough to handle them on the session. If for you this is not the case, I can't say why exactly that wouldn't work. But if it's not the case, then you could simply implement this interface, which will tell three things. One is how to generate a token. You want a specific kind of token and you generate it. Where to save it? Do you want to save it in a database maybe instead of the in memory? You can do that even if you still want to keep it linked with the session. However, I wouldn't really understand why, but you can do that if you really want. And of course, load token, how to get the token. If you store it in a database, you can load it from there. So you see, Spring Security is actually highly customizable also in terms of how CSRF protection works. You most likely will simply use the default all the time. I don't recommend you disable, and if you need to disable it, you might need to only disable it for specific endpoints. Then use the ignoring request matches and make sure that you understand why you disable it. And I think that's a summary for, can I take one more look in the live chat before we close the session and see if it's something that I can answer. So should I configure something in bin, public security filter chain, in part of session management if I use Spring Session? I think this is a bit of a different question than the topic. So let's check out about it later. So find me on Twitter, on LinkedIn, or simply write in the comment section, and let's take it outside of this video. Must the CSRF take when the users first perform a GET request? Yes. What will happen if an attacker or someone just sent a post request? I'm not sure if I understand the question, but if someone sends a post request and the application is protected by CSRF, they will get back a 403 forbidden, as you have seen me struggling with here for about 5 minutes or more, and nothing will happen. I mean, they will not fulfill into managing to impersonate the user. No control is mapped to that request. No, it was actually mapped correctly, as you have seen. It's just my brain using something else instead of the parameter name. And in Spring Security, if CSRF token is disabled based on business logic, how to bypass SonarQube rule settings which mandate CSRF. You have to configure SonarQube. If you have SonarQube and you have a real business logic where you have to disable the CSRF protection, then you can also configure Sonar. It has its rules which can be configured. It has more profiles of rules that you can configure, and you can choose to have a different profile, or you can simply choose to completely get rid of the rule from the profile. I mean, you can do it in several ways. Then of course, if you have a case where you have to disable CSRF protection, you need to, and you have a SonarQube which makes the pipeline fail when it finds that, then of course you need to figure out how to exclude the rule, or at least exclude the rule for that specific case, so that Sonar works further, and maybe even document why you did that, because maybe others in the future will not understand, maybe will consider that a mistake and will try to put it back. I've seen that also. And with that being said, I think I can say goodbye also for this session. So I think we managed to discuss a lot of things. I hope CSRF is more clear in terms of what the attack is and also how the protection works, and also how can you configure it with Spring Security, and which are the best practices. And let's meet next time and discuss some other subject. If you have questions, if you continue to have questions, remember that you can always find me on Twitter, LinkedIn, here in the comment section, and we can discuss further. Up to next time when we meet, I'm waving goodbye and I'm saying have an excellent time for learning further.